Hello, we have been studying discrete random variables. We denote these variables by capital letters X, Y, and so on. And let's say I call it X, and let's say that this discrete random variable can take the values X1 all the way up to Xk. And we can also write the probabilities associated to these X values that the variable takes. We call them sometimes Pi, is the probability that X takes the value Xi. And this is for I going from 1 to k. Okay, so for such discrete random variables, in the formula booklet, we have the formula for finding the expected value. We need to multiply the values xi with the probabilities and then sum over all the possible xi's. We can also find its variance. We have a formula over here, but most of the time we are not going to be working with this rather complicated formula. We're going to be using the calculator instead to find the standard deviation, which is the square root of the variance, and the calculator can tell us what this is very easily. Now, in this video, what we'll be looking at is how does it behave, a new discrete random variable that we create by multiplying x by a and then adding b, where a and b are real numbers. This is a linear transformation of a single random variable. In the formula booklet, they call it like this. And we have a formula that says how to find the expected value or mean of such a random variable and how to find its variance. There is no formula for the standard deviation, but let's just write it down. This is going to be very easy because it has to be the square root of the variance. So what's square root of a square variance of x? And that means this is the absolute value of a multiplied by the standard deviation of x. So it's not in the formula booklet, but you can deduce it very easily because you know what the variance and standard deviation are and how they are related. So what's about this discrete random variable? Well, we are going to see an example that I hope gives some light into what we are doing. But before that, in example 1, I just want to show you that you can just apply this and find stuff even if we don't know yet exactly what's going on. We have a discrete random variable x with expected value or mean 7 and standard deviation 1.05. And we create a new random variable that we call y, given by 3x plus 1. And we want to find its standard deviation. Its expected value and standard deviation. For the expected value of y, we apply the formula. We're going to have to multiply 3 times the expected value of x plus 1. So 3 times 7 plus 1, so this is 22. We found it. We also want to find the standard deviation of y. So we are going to multiply 3 times the standard deviation of the original one, so this is 3.15. So that's it. We can solve the problem because we can apply the formula because it's in the formula booklet. Now, what is really going on here? I like to have in mind a nice example of everything that we study. And here is the nice example I want you to look at over here. I think you should stop the video for a little bit so you can read this example from the textbook about a salesman called Dominic. So the information that we have is that each day he earns 100 of whatever the currency is, let's call it dollars, and then plus 25 for each sale that he makes. He has a probability distribution for the number of sales that he will make. They will be between 0 and 5, and we have a table where the probability of making 0 sales, 1, 2, up the way up to 5 is given. The first thing that we want to do is to find the expected value, variance, and standard deviation of the random variable that tells us the number of sales he makes per day. So, for instance, to find the expected value, we'll need to multiply 0 times its probability, so 0.17, plus 1 times 0.25, plus, and so on. The last number will be 5 times 0.03. We could do this by hand, but before we do it, let's notice that if we do it in the calculator, we're going to need to use the calculator to find the standard deviation anyway. So we can find the expected value, the standard deviation, and then consider the square root to find the variance. So let's do that instead. Let's switch to the calculator and take a look at this. I already entered my table over here where we have the first column, the sales from 1 to 5, and in the second column, their probabilities. So let's go to menu and statistics and stat calculations. One variable stats, that's what we want. We have exactly one list. Our list is the one that we call sales, and the frequency list is given, but the probabilities, I call it probab because I had something else called prob already. And I would like to see the results on the column C. So let's do this. Okay, so we got that the expected value is 1.85. We also got that the standard deviation is down here, is approximated to three significant figures, 1.31. So let's go back to our problem. We can find the variance. Let me not go back to the calculator again. We'll need to do 131 square. Not a big deal. What interests me more is what comes next in part B, where it says, suppose Y is the amount of money Dominic earns in dollars per day. We want to write Y, which is a new random variable, in terms of X. So how does he calculate how much money he makes? Well, it says over here that for each sale that he makes, he will get $25. So we multiply 25 by the value of X because X tells us the number of sales per day. And then we need to add 100. So this is our new random variable. And it's in the form that we were considering before as Y is equal to aX plus b. So now we can find what is the expected value of Y and what is the variance and what is the standard deviation. We could, because we know what the definition of Y is and we have the values for X, we could make a new table with the Y values and the probabilities associated to them. For instance, when X is equal to 0, we will get that Y is equal to 0 times 25 plus 100, so it's equal to 100. And the probability of Y being equal to Y will be 0.17. I could continue my table like this, and then I could enter the table in the calculator and I could find the expected value, variance, whatever I want. But I don't need to do that because I can use the formula from the formula booklet and see that the expected value of Y is 25 multiplied by 185 plus 100. And the standard deviation of Y is equal to 25 multiplied by the standard deviation that we found before, 1.31. Okay, I will let you do these calculations yourself. What I wanted to show you is why will we want to make a new random variable? How will that make sense? Well, here you have an example of how it makes sense, and then we can just apply the formula from the formula booklet.